Hello AP Stats. Hopefully you have printed out this problem, quiz 12.1c, and I'd like for you to run this test, try it on your own, and then you can either watch and go through your answers or review, go to the end and check your answers and rewind to see whatever you need to see. But on this problem, we have a high school administrator who is concerned about the amount of sleep the students in the district are getting and selects a random sample of 14 seniors in his district and asks them how many hours of sleep they get on a typical school night. He then uses school records to determine the most recent grade point average for each student. His data and a computer regression output are given below. Do these data provide convincing evidence? Provide convincing evidence, that usually means a test, of a linear relationship between the hours of sleep a student typically get and their academic performance as measured by their GPA. Carry out a significance test at alpha equals 0.05 level. Okay, so as usual, we're going to start out with naming our test. We're going to perform a t-test for regression or t-test for beta, where beta is the true population slope of the LSRL of the relationship of high schoolers, or perhaps high school seniors. Okay, so next we want to write our hypotheses. Our null for a beta test is always going to be that beta equals 0, because if there's no relationship between the two, which is always our assumption, then the slope would be approximately 0. And our alternative, sometimes hard to see, could be beta is greater than 0, beta is not equal to 0, or beta is less than 0. And if we look back in the problem, he doesn't ever say the direction here of his test, but it does say, do these data provide convincing evidence of a linear relationship? It doesn't say high or low, even though we assume one direction. Don't put that in your test unless you know for sure which way we're testing. So we're going to do not equal to. Okay, so next we want to check our conditions, and as I said, you won't do this on an exam. You won't have to go through all your conditions if you're running this test, but it is quite possible that they will ask you to. So we're going to go through them here. So the first thing we're going to do, LINER. First test is a linear relationship. I'm just going to write over here conditions. Is there a true linear relationship in the population of sleep versus GPA? And of course we can't see the population relationship, but we can look at our sample. So I'll take my calculator, and I have already put in the list, in list 1 and list 2. I hope you can see that. And then I went to plots. Well, I went ahead and ran the regression on F4, of course, to get the residuals first. And then I went to plots and plot setup. And under plot 1, I went ahead, okay, let's see, a little bit of a glare on that. Okay, under plot 1, I went ahead and chose a scatter plot, put in list 1 and list 2 to get my scatter plot. And I will enter that and zoom data. And there's my scatter plot. I did also store my line in Y1 when I ran the regression. Remember, you can always choose that, which kind of helps. And as we can see, it's really not a great linear relationship, but we would just describe it as we always do. There appears And then we'd need to make sure, if you're referring to this to the scatter plot on the calculator, make sure you sketch it out. And this isn't going to be a great sketch, but we can make sure that we're showing GPA and sleep and showing that we actually saw it on our calculator. Okay, and I is independent. And there's two things we can think of for independent. Since these are randomly chosen students, then we would assume that the amount of sleep they get and their GPA would be independent of one another. So we can list that, and we can also, since we are sampling without replacement, we would want to say 10 times the sample size, 14. The school should have at least 140 seniors. I think we're talking about just this particular school, and perhaps I should have said that when I defined beta as well. Also, we'd assume GPA and hours slept between randomly selected students would be independent. Okay, so that covers everything. A lot of writing here. That's why we don't do the conditions often. Okay, N is normal. I think this one's the hardest one. Remember, you're trying to see that in the population, that for any given X, those Y values are normally distributed. So the only way we can check that is to look at the residuals and to graph them somehow on a normal probability plot or a histogram or even a box plot, and see if they're approximately normal. So I did do that. If you go to plots and normal probability plot, now make sure to get your residuals, you should always make sure you've run the regression first, so the residuals in there aren't the residuals from your previous test or your previous regression. And so we chose the second one, normal probability plot. And here under list, make sure you go to stat bars. So I've closed main. Remember, you can go right or left to open and close a menu. So I've closed main. I go down to stat bars and I choose residuals to put in that list. Okay, and then if we go to the graph, I'm going to first deselect my last one and select the normal probability plot and zoom data. And so there's my normal probability plot. Not a bad linear relationship. Okay, so I need to sketch it out. You can call it the NPP here. And the normal probability plot always has residuals, or not always has residuals, but your X here and up here is going to be your Z-scores. And so let's kind of sketch this out here, kind of a little hook right in there. Okay, and then the normal probability plot of the residuals looks to be, and you really just need to talk about how linear it is. You don't necessarily need to say it's normal or approximately normal. Looks to be somewhat linear. Okay, last two. E is for equal variance, meaning any given x, the variance, the spread across those y values is the same throughout the population. So the only way we can test this is to look at our residual plot, and so we're going to have another graph. So a residual plot, I've already put under plot 2 here, and you should know how to make a residual plot. You're going to just do a scatter plot and put your residuals as the as the y list. Your x list is still going to be list 1. And there's our residual plot. And you can see it's kind of hard to tell because we don't have a lot of points, but it does seem to have a pretty equal scatter across. You're looking for how spread out it is. We also could use this residual plot up in linear to talk about, yes, this isn't a great linear relationship, but since the residual plot is randomly spread, it does seem like the linear relationship is an appropriate model. But here we're just looking to see if the spread between these dots as the x's get larger is pretty much the same. So we'll kind of sketch that out a little bit. This is sleep. This is residuals. Sketch it out best I can. And we'll talk about seems to vary. The residual plot seems to vary equally from 0 for all values of sleep, at least all the values that we have. Okay, and then last one, R, random, and this was a random sample of 14 seniors. So a lot of conditions there. Like I said, don't get too worked up on that. So now we run the test. Our test statistic, T equals B over SEB. And no, if you're given a computer printout, you're usually going to have this. Here is our B right here. Our slope is 0.10197. Our standard deviation of B is right here, 0.04387. So it never hurts to write those in, but our t-score is given to us, so don't bother calculating it. It's 2.32. Our p-value is given it to us. Make sure we're going along the sleep line because that's our B, our coefficient of the x. Our p-value is 0.038, which is less than alpha. Since our p-value 0.038 is less than alpha, 0.05, then we will reject the null. And say that there does appear to be a linear relationship between sleep and GPA among high school students or high school seniors. We didn't talk about degrees of freedom. Do know in this test degrees of freedom is n minus 2, which would be 14 minus 2, 12. If you have to find the t yourself on your calculator, remember you're going to go to Lin Reg T-Test and enter these things. Enter the to list and it'll run it for you very quickly. But remember in your conclusion to do put in the context. I haven't done that right here, but that we have enough evidence to conclude there's a linear relationship between the hours of sleep that students typically get and their GPA. Okay, on the back here it says construct and interpret a 95% confidence interval for slope of the regression. Okay, so this doesn't take much work beyond. We've already found the conditions and checked it. This is called a t-interval for slope, or t-interval for beta, the true slope of the regression line as we defined it before. We will do a t-distribution with 12 degrees of freedom for a 95% confidence interval. And so to find t-star, we can look it up in the table for 14 degrees of freedom and a 95% confidence interval. Look it up, make sure you're getting it, because a lot of y'all, this is where you're having trouble. It comes out to be 2.179. If you want to use inverse t, you can, but remember, for a 95% confidence interval, if this is 95, then this area to the left is 0.025. And so if you're looking for the opposite sign, you don't want to put in the negative of this t value, you can put in inverse t of 0.025 and get it that way, but make sure you report the positive. And also, you're going to be putting in your 14 degrees of freedom. Okay, so our confidence interval is b plus or minus your t star times the standard error of b. So we can use from the previous page, our b was 0.10197. We have our t star, and the standard error is 0.04387. So if we wanted to run that whole thing on our calculator, we go to the stats list editor. We have our list in. We're going to go to F7 for our intervals. Hopefully you can see that. We're going to go to linreg t interval. We're going to go ahead and enter list 1 and list 2. Keep frequency the same. We want an interval for slope, so make sure this is selected as slope. Enter. And it gives us all our information there, and the interval ends up going from 0.007 to 0.1965. So make sure we say our conclusion correctly. I am 95% confident that the interval from 0.007 to 0.1965 captures the actual slope of the population regression line relating GPA and hours of sleep for high school seniors in this district. So we're talking about the population, and we're 95% confident. Okay, and then the last one here says, can we conclude from these data that students' GPA will improve if they get more sleep? Explain. So this is actually asking, is there a cause? Is there a causal relationship? And as you know, we can't conclude that additional sleep, and this is the cause of the association of an increase in GPA. Since this was a sample survey, it was not a controlled experiment. There may be other factors that are confounded with the amount of sleep that the students get. So make sure if it's asking for a causal relationship, you think, well, was this an experiment? It wasn't. It was a survey. It was not a controlled experiment.